Welcome, engineers. My name is Travis IQ, and today we're going to talk about bathroom remodeling. No, that's not the case. We're going to talk about cybersecurity topics. We're talking about the certificate infrastructure, certificates, and certificate services. So let's think a little bit about what certificates are and why we need them. So certificates serve to facilitate authentication, who you are on the internet, right? Or as a remote server, maybe not on the internet, maybe you're on some big LAN infrastructure, right? But what we need is a mechanism to prove who you are. Do we have this in the real world, Travis? We do have this in the real world. You have a little ID, a certificate that proves that you are you, whether it's a government issued ID card, a driver's license, a passport, right? And on that card, there holds information about who you are, your date of birth, where you're from, right? And then also there's another component of this card, which is the verifying body, right? The state that you are from, the US government for your passport, the state for your state issued ID, these things, right? So we need the equivalent of this in the digital world. Now, in the digital world, our state isn't going to verify who you are as a server, right? We're going to use some service to issue you these certificates, an authoritative certificate, right? A certificate authority, as it were. We need to contain a few more pieces of information in that certificate, right? Domain information, because you're probably going to be registered as a website, right? Validity dates, like you would have on your ID card, as well as a public key, right? Which is a mechanism to facilitate in-band key exchange, which is pretty important. So our certificate services facilitate a couple of things, right? And we actually talked about these concepts previously in some of the previous videos. If you haven't seen them, check them out, right? We talked about the concept of authentication, who you are. Who you are. Non-repudiation is a topic we've mentioned as well. Non-repudiation is the concept that you cannot dispute that you sent a transaction. It came from you, or you sent the information. And we'll talk about how our certificate services help facilitate this as well. And then if we're exchanging public key information and I'm using my private key to facilitate bulk symmetric key exchange, right? Symmetric key exchange for bulk encryption, then it's helping with our encryption infrastructure as well. Okay, so how do we do this? This is the more important question, right, Travis? Okay, so this is what our certificates are intended to do. How do we facilitate this? Okay, well, where does the certificate come into play? First and foremost, right? The host, TIQ, is communicating with intelligencequest.com. Quest.com. I request the setup of a TCP connection and an SSL or TLS session, right? In the case of HTTPS, HTTP secure. And the website responds with a certificate. What is contained in this cert? Again, remember, we talked about what's contained in the cert to some extent and what the purpose is, but who you are. So the domain, intelligencequest.com, is contained right here. Validity dates, something like 2 years is a very common validity range, right? As well as my public key. There's a few other things in here. If you were to go and look at certificates that are associated with websites through your browser, Firefox, Chrome, Brave, Edge, whichever your browser of choice is, then you'll see a few more things. But suffice to say, these are some of the key components of the certificate. And then at the bottom, there'll be a signature. A digital signature. This digital signature attests to the validity of this certificate. Let me get my head out of the way there. I can't very well sign my own cert, right? I don't go and present you with a driver's license that says verified by Travis IQ, now do I? No, this is a third-party verifier. This is a concept that we actually haven't talked about that's really important in the certificate infrastructure and needs to be discussed right now. That's the concept of digital signatures. Digital signatures. What is a digital signature? Okay, let's think about the exchange of information here for a second. I'm exchanging information with this server. When I exchange information, there are a couple of concepts that we're familiar with here. When the server responds, let's say I request SNMP info, or I request a file transfer via FTP, right? And the server responds and also includes a hash. So we have a message, we have some information, and then at the bottom we have a hash value. Remember, hashes are our digital fingerprints of this information. This hash value represents a digital fingerprint of the info that was being sent. And when I receive the information, I look at the info, I calculate the hash, I compare it to the attached hash, and I know then that the data has not changed. You may say, hey Travis, what if Eve is listening in and Eve intercepts this message, changes the message to something else, blah, and then hashes it and forwards it on. Travis is then going to instead only look at the message that he received, right? Because that's the only thing I know about. So I'm going to look at the message that I received, calculate the hash, compare it to the attached hash, and lo and behold, they match. So this hashing mechanism doesn't actually do what I was hoping that it would do. So instead, I could, if I wanted to, take and encrypt this hash. And you might say, Travis, why wouldn't I just use a bulk encryption mechanism like an asymmetric encryption algorithm like AES? Now, if Eve sees this, she couldn't even decrypt the hash if she wanted to, couldn't change the hash because she doesn't have the AES key. I do, because both Intelligence Quest and I exchanged the same asymmetric key. And now I decrypt this and calculate the hash, verify the hash, and I know the data has integrity, and I know that it hasn't changed in transit. Okay. Travis, you still haven't defined a digital signature. What I've actually defined here is known as an HMAC. Hash-based message authentication code. Okay, what's the difference between an HMAC and a digital signature? There's still an issue with this HMAC. What is the issue with this HMAC? The issue is nothing to do with the integrity or the data in transit, actually with the endpoint. Right? If someone other than intelligencequest.com established this encrypted session with me, if say Eve, right, established this encrypted session with me, I don't have any way of verifying that it came from the server and not Eve as being forwarded on as some man in the middle or something like this, right? I don't have any mechanism of authentication, right, or non-repudiation proving. I can't prove that it has come from Intelligence Quest no matter what. All I know is that we exchanged these symmetric keys, and hopefully we exchanged them and they were non-observable, and we used them to establish this secure session. But I'm not positive. Okay. We have finally gotten to the point where we should discuss digital signatures. A digital signature is all of these things and more. Wow, Travis, sounds wonderful. And I guarantee you, it actually is a really interesting concept. What an elegant solution. I talk about this all the time in some of my live courses and things like this. What an elegant solution to such a difficult problem. I feel like they've done this a lot. The TCP/IP stack, for example, symmetric and asymmetric encryption, hashing algorithms, all these things. Elegant solutions to non-trivial problems. Okay. A digital signature. Intelligence Quest formats a message, hashes the message, and then encrypts the hash with Intelligence Quest's private key. Now I know it came from Intelligence Quest. Again, the concept of asymmetric encryption. The only person who should have this private key, or the only entity that should have this private key, is Intelligence Quest. It is now encrypted with a private key, and then you would say, well, anyone with the public key can decrypt this hash. I agree with you. Even if Eve is listening in and knows Intelligence Quest's public key, which is fine, she can decrypt this hash, look at it, but cannot re-encrypt a new hash and slap it on this message because she doesn't have this private key to do that with. If she were to encrypt with a public key, the only person who could decrypt that, or the only entity that could decrypt that, would be the private key, right? So now what I've done is I've facilitated message integrity with the hash. I've guaranteed that it's maintained its integrity through in transit, right, through encryption. And I've guaranteed non-repudiation of the source, which is Intelligence Quest, through the use of private and public keys. Now, in the example that I've given you, Intelligence Quest is using its private key to sign this message. In the case of certificates, I said Intelligence Quest can't sign its own certificate, right? And this is correct. So in the case of certificates, I need a trusted third party, right? In the case of IDs, it's your state government or the federal government. In the case of passports and things like this. In the case of the digital world, it's certificate authorities. Certificate authorities, a CA. An example of a certificate authority would be something like Let's Encrypt. Let's Encrypt wouldn't necessarily give me the most authoritative certificates, but it's easy to use and automated, so we'll use it. Okay. So now in this certificate that Intelligence Quest is going to provide me, it has their name, an identifier, their domain, .com, right? We won't write it all out. Validity dates, valid through, public key, and method through which the public key was generated, right? So RSA 4096. And this is presented to TIQ. I then look at this information and go, okay, I agree that it's you. I take and I look at the digital signature. And this digital signature was actually signed by the CA. The entire certificate is actually provided by the CA. And we'll talk about how you would get a certificate issued, certificate issuance, certificate signing requests, validity checks, and certificate revocation lists and things like this in the certificate infrastructure portion. This is just certificate services as a whole. And so I take, let's say, Let's Encrypt's public key, and I decrypt this hash. I get a hash value. I take a hash of the message. I compare the two, and they are identical. I know this certificate has not been changed in transit. I know that the domain has been validated by the certificate authority. So I trust the certificate authority, therefore I trust this domain because the certificate authority has validated that this is the domain, this is their public key, and these are the dates through which it is valid that I have verified them for. So I know that they are valid. Now we can use asymmetric encryption to exchange bulk symmetric encryption keys and generate a confidential session, right? Maintaining confidentiality. If I move my head, you can kind of see that over here. And this completes our certificate infrastructure discussion. Again, there's more here in terms of certificate services and how they're doled out, but we'll save that for a later date. As is always the case, engineer, break stuff, and have fun. And if you liked the video, like and subscribe. We're throwing these up twice a week. Let's do it.